Hello everyone, my name is Chen Zhang from Intel OTC. I'm from Shanghai, China. My topic is application-agnostic high availability solution on hypervisor level. The first is agenda. Firstly, we will talk about background introduction, and then we will talk introduction, cross-gram log stepping. That's COLO. The next, we will talk the new changes and performance and the customer. The last, we will talk some future work about COLO. That's the background. The non-stop service with VM replication. With the development of IT infrastructure, most of people migrate its service from physical machine to the virtual machine. So in this background, if they want to make their service always running, they need to do some high availability related job in their service. So they have they make in this time they must make a decision to do this high availability job in application level or in the hypervisor level. If they want to do this job in application level, they will handle much of work. Because application always changing, and if the application if the application changes, the high availability job will more complex. So in this, so here the hypervisor level high availability solution shows advantage. In this diagram, we can see we have two nodes, the primary nodes and the secondary nodes. That's both physical nodes. And user service running in the guest OS. If some hardware failure occurs in the primary node, in this time, this system will detect the failure and switch the service from the primary node to the secondary node. We named this forward. Let's introduction COLO. Firstly, we must talk the client and the service model, because COLO's design based this model. If we make guest OS as a server, the client will connect to the server through the network. They will send a request to the guest OS. Guest OS running user's application and do some response. For example, if somebody want to read some news, they will access some website we can image the website running in the guest OS. So they must, their device like the smartphone will send a request to the VM, like say we want to some news, and the server will send a response. In this time, the client only care about the response. The COLO as we know, have some of existing high availability solution in the hypervisor level, like micro checkpoint or Remus. And COLO compared with that existing solution have some advantage, like primary VM and secondary VM execute in parallel. And the micro checkpoint and the Remus not compared. The COLO will compare the output package from primary VM and the secondary VM to detect VM status. COLO will synchronize the secondary VM state with primary VM when the response are not identical. Compared with Remus or micro checkpoint, they will stop the secondary VM and wait to next checkpoint. They do a periodic checkpoint from the primary node to the secondary node. And this time, the network network package must be buffered. So the performance is very low. And COLO has a big advantage about the network job. Let's talk about the scenario. Basically, COLO can support both services. But for the real cases, we can divide the network service to stateless service and stateful service. Like UDP-based application named the stateless service, and the TCP-based application named the stateful service. They have both service have its own advantage and disadvantage. Like the UDP-based application can have the low latency, and the COLO is designed for the stateless. They're not designed for the stateless service, but for critical stateful service. Our solution can protect your service even from physical network or power interruption. That's why COLO better compare with micro checkpoint and Remus. We no buffering introduced latency and less checkpoint frequency. For example, the Remus in real case, the Remus we must set the checkpoint frequency like 100 ms. The COLO can set the periodic checkpoint as 10 seconds or longer. So for the network application, the COLO's performance is very high compared to the micro checkpoint or Remus. And compare the instruction lockstepping. That's the old design. This design will sync the processor's instructions, and they have lots of issues. So that's COLO history. In the 2013 COLO paper published on SOCC, and in the 2015 COLO framework merged by Xen. This framework based on Xen live migration and Xen Remus project. And in the 2018, all COLO-related patches merged by QEMU. This time have a lot of business because in our original design, COLO network-related job just running in the kernel space, like domain 0, but we have a lot of concerns. We communicate with kernel community. Finally we dropped this design and redeveloped the COLO network-related job on the QEMU space. That's user space. They have a lot of advantage. I will talk in the next. And now we have some new features. That's the old COLO architecture. In this diagram, we can see COLO have three models. The COLO frame that's in Xen space, and COLO-Proxy and block replication. The old COLO architecture, just the block replication in the QEMU space, and the COLO-Proxy in the domain 0 kernel space. We compared this diagram with the new. That's the new COLO architecture. We moved the COLO-Proxy from kernel space to the user space. We have a lot of advantage. In this diagram, we can see some of network I/O and disk I/O. I can explain it in detail. Firstly, we can see the orange arrow in the primary node from the external network. That's from the client, like your phone or something, to send a request to the primary VM. They want to get some information or something. So the request from the external network, firstly they will throw the COLO, the Xen, and to the QEMU side. QEMU side, the COLO-Proxy will mirror this request to the primary VM and the secondary VM. At this time, the primary VM and the secondary VM that's running parallel. So the guest, the two set guests will get the same request. So the user application gets the request, will send some response. We'll want to send some response to the client. So we can see the black arrow in the primary VM. The response will will be sent to the COLO-Proxy firstly, and this time the secondary VM will send its own response to the secondary COLO-Proxy, and the secondary COLO-Proxy will redirect this response to the primary node's COLO-Proxy. And here the primary COLO-Proxy get two-side response net packet. So they will compare this packet in the primary node COLO-Proxy. So if the network package is same, I say the workload is same, they will within the primary node and primary VM and the secondary VM, the state is same. So we have nothing to do. We just send the package outside. If the packet is not same at this time, we think the primary VM, the state is different with the secondary VM. So in this time, the COLO-Proxy will send a message to COLO frame to notify the COLO frame do a checkpoint. The checkpoint job mainly we can see the checkpoint job like live migration. They just migration the primary VM to the secondary VM for the memory, and this time the VM state can be same, can be forced to same. And that's the network and the COLO frames job. And another one is block replication. The block replication's main job is to redirect the primary VM's write request. They will send the write request to the secondary block replication. And in the primary node, they will write to the primary node storage. The secondary node cannot write to the secondary storage directly. The secondary VM will have another write request. So in this time, we will buffer the two write requests and until the next checkpoint to decide how to handle this request. Another modules, the last module is heartbeat. This module we can make it as a normal application running in domain 0, or we have internal heartbeat in the QEMU. Okay, that's the difference. The old COLO-Proxy based on kernel net filter module. That needs user manually patch and rebuild the domain 0 kernel. So that's not easy for the user. The new COLO-Proxy code all implement in the QEMU, so they no need to modify the kernel. And the COLO's code have been upstream to the QEMU currently. So user just need to clone the upstream QEMU and make it can use COLO, currently. Currently, the user space proxy have more generic code, split this COLO-Proxy job to four modules: filter redirector, filter mirror, and filter rewriter. and the colo compare. The four modules related to another, communicate to other, use CHA-DV socket internally. That's a detailed diagram. That's for the block replication. We can see the detailed step, how to send and write the request to the storage, and how to handle it when occur checkpoint and forward. When occurs a checkpoint event, we will drop the secondary VM cache. If occurs a forward, we will write the secondary VM cache to the storage. Because in this time we think the VM's failure may be caused by the previous block write request. So we will write the secondary VM's cache to the storage. That's the colo frame. This module just reuse the Xen log migration codes. Just track the dirty page and send to the secondary nodes. That's new changes. New changes is COLO-Proxy design. Currently, we all implement in QEMU. And based on QEMU NetFilter component and SLIRP component. This component is a user space TCP/IP stack. And the detail, you can see the QEMU docs have a file named COLO-Proxy. That's the COLO-Proxy design, the kernel scheme. We can see the COLO-Proxy in the kernel space, and the step is same with the user space COLO-Proxy. That's the user space. We can see the COLO-Proxy move to the QEMU space. And the step I have talk about it. That's internal connection. The mainly four modules how to communicate each other and to this whole system. That's the new features. We developed integrate colo heartbeat module. This module just in QEMU side. That's user can easily enable colos. All features didn't need the external heartbeat interface. And the internal heartbeat can reduce the time of fault detection and response. Another one is we enable the continuous backup. Continuous backup the VM after forward. Let's talk about the performance and the customer. That's the performance data. We can see about this data. We compare the colo VM with the native VM in the same physical machine. Firstly, the kernel build. We can see the colo COLO project have less influence to the kernel build performance. For the network-related performance, the UDP stream or the UDP netperf, we have about half of performance compared to the native VM. And the TCP is lower because we must compare the net package to decide whether we will do checkpoint or do nothing, just send the package to the outside. So for the network, we have to lot of optimization. Yeah. Currently, we in the compare work, we in the QEMU we open an independent IO thread to do this job. And for customer, I just can say something about that. Currently, customer is Huawei and this stack, a Chinese CSP. And the future work, we will do some bug fix and strengthen stability. We will do some shared storage support and network performance optimization and the libvirt support. Okay, that's all. Have some questions? Hello?
I'm just curious, have you ever actually had a real failover like in production and have it sort of work? I'm just curious.
Yes, in the Huawei, they have a productive they have a product. Yeah. The product has a COLO feature. So in this product, they have some use case for the critical service. Yes, the test we can if the primary node cut down the network or the power, the COLO can switch the service. Yes, the time about 1 second or less. Yeah.
Cool. And is all this stuff with QEMU, is that integrated now with the Xen code? If someone downloaded Xen 4.12, would they be able to use stuff out of the box, or is there more stuff that needs to be upstream?
Currently, COLO's yes, this diagram. Currently, COLO's most of codes in the QEMU.
Right.
Yeah. So just the COLO frame in the Xen. So currently it worked well in my test.
Okay.
Yeah.
Okay.
Hello.
So we were testing COLO in OSS testings and upstream, but it kind of broke and there wasn't really anybody around who seemed able to fix it, so we dropped that. Are you interested in repairing that and getting that tested then upstream? I think that would.
Yes, recently I sent a patch to fix some issues because the COLO project currently, because some of previous job we implement COLO in the QEM side. So in the Xen side, have some we must do some update job. So recently I have sent a patch, and in the future I will send a much patch about that.
Sorry, you say Linux changes are needed as well?
No, the QEM side, QEM and QEMU.
Right.
Yeah, so in the QEM side, the COLO have two versions. One version is the Xen COLO, and another version is the QEM COLO. Yeah, the QEM side, in the QEM side, we currently work well, and for the Xen side, because some changes in the QEMU, so the Xen side we have to do some update job. Yeah, currently I have sent a patch, and
right. I saw some libxl patches. So this is like a segue. Those patches, I'm not sure if I'm up to date on what was written on the list, but we got the impression that those changes, that it's not compatible. That is, you can't, that the changes in QEMU have already gone in, and that the existing Xen code before your recent patches is no longer compatible with upstream QEMU. Is that right?
yeah.
Okay. Well, we should probably just take those patches then, and I look forward to your hopefully some contributions to the testing.
Okay, okay.
Because we'd like to test this, and if you get it tested in OSS test, then if somebody else breaks it, that would be a blocker for
They have to fix it.
and
Yeah.
and things, and people have to fix it.
Yes, yes. Any questions? Okay, thank you, everybody.